So fraction comparison with color rods, and I'm using this online app here. Something to keep in mind, whenever possible, when I'm working with kids, I am not going to have them on the computer. We have way too much time on screens, phones, tablets, laptops, whatever. My hope is you would have a physical set of these in the classroom. And more schools have these in the classroom these days. In this class, we're doing them online because almost everyone enrolled in this course is online, and I can't easily get you a box of these toys to your house. So again, we're using these because we don't have easy access, but hopefully your classroom does. And what we do with the color rods when we're playing around with kids is we have to pick a rod to be whole. And so in this case, the dark green is going to be one hole for this example. So with that in mind, I want to compare it to the other ones. Like, how does the white compare to the dark green? How does the red compare to the dark green? And I have these laid out on a grid. Kids would just stack them up next to each other to make those comparisons. So when I'm comparing the white one, I can go grab more whites to double check that when I line them up, I get 6 of them line up to make that. So I've lost that one somehow. Yeah. So here I can see the white is 1/6 of the dark green. And then the red one, I can line up some of those. So we have the kids play around, make a train out of the red ones. And I can see I need 3 of them to make the dark green. So one of them would be 1 out of 3 equal parts. Try the purple. Space here. I grab a purple. Now here things don't work out quite as nice. So I gotta say, all right, well, they don't line up. So I have, 1 plus a little more makes that, but not quite. So there's a couple of different options on how to do that. I could stack a bunch of them together until they line up using the idea of lowest common multiple idea, or I could try to use another block to help me figure that out. Let's see if I bring some more reds in. You do not want to sit on top of the purple. Oh, it disappeared. Whoa. Okay, the app is freaking out on me. It's not happy about me moving stuff. Different then. Purple up there again, and then some other reds. So I could try a smaller shape to see if I can use them to be compatible. And at the very least, what we have are the white blocks to make the comparison. So here I have a couple of different options on how that can happen. So I'm going to use the white ones first. So for the purple, I can see that 4 white blocks make a purple. And for the green, I can see there's 6 of them. The dark green. So I have 4 in there, I have 6 in here. So the comparison would be something like a couple of options. The purple is 4 out of 6 of the dark green. And so I'm using the 1 as my common denominator to make that happen. I could make other statements too, because I saw I could use the reds to make that happen. As far as the red is concerned, I see that there are 2 of those reds in the purple, And there are 3 of those reds up there. So I can also say, based on the red comparison, the purple is 2/3 of the dark green. Which is the better answer? Well, they're both great answers. Now, we're used to saying we ought to always reduce, but there are some circumstances where it's okay to not reduce. And that having a 1 as the comparison is okay. And saying 1 is 4/6 of the other is okay. So often we like to simplify fractions, reduce them. We'll talk more about that later. But there are multiple ways to represent them in terms of denominators. One more. Let's take a look at the brown comparison. That. Clear the whole screen. All right, so the dark green is going to be my whole, and I want to compare the brown to it. Now, all the other comparisons, the other shapes I picked out were smaller. This time the brown is bigger. And they don't match up perfectly, because if I take more than one green, I can see the brown is not quite a match for that there. So I have to decide which other blocks I want to use for the comparison. And for sure, I have the white. And I already saw there were 6 of the whites there, and it looks like I just need 2 more of them to make the brown. So I'm just going to make a note of that. So there are 2 more than 6, so that would be 8 total here. So just based on that comparison, the order of the other ones, if I want to compare the brown to the green, I would say something like the brown is 8/6 of the dark green. Now notice we have a top-heavy fraction here where all the other ones were the top number was smaller. This time the top number is bigger. So that's one comparison. So since I have 2 right there, I'm wondering if the red would work out nice. So I'm going to drag the red over. Underneath this time. So how many reds do I need? Okay, so I already knew there were 3 for the green, and it looks like 1 more makes the brown. So using the red shape, I can make another comparison. So here I found there were 1, 2, 3, 4 of them. So the comparison would be 4/3. Brown is 4/3 of the dark green. Now, since I'm comparing to the dark green, it pretty much dictates what my denominator is. Okay, and I was looking at it as 6 groups of 1 or 3 groups of 2. If I consider it again as a whole, then for sure the brown is 1 whole dark green plus that little bit of extra. Well, how much extra is that on there? Well, the dark green had 3 of those. So another way to think about that, pull this out, this out, this picture. This one right here, I can say something like brown is 1 1/3, right? That extra chunk there is 1/3 of the green. So I can make, there's 3 different ways I can basically say the same thing comparing the brown to the dark green. The brown is 8/6 of the dark green. The brown is 3/4 of the dark green. I could also say the brown is 1 1/3 of the dark green, which is the better answer. Depends on your perspective on better. If I use the 1 as a comparison, which is very nice to use and that jumps up at a lot of people easier than the red 2 does, then the first answer is the best one. If I'm thinking about a comparison with fractions that I want to, like, in everyday language, I wouldn't say, hey, go drive 4/3 miles down the street to get to my house. I would say drive 1.1 miles. So when we're speaking, we often say 1 1/3 more often than we say 4/3 when we're saying these numbers. But these fractions that aren't mixed, this is a mixed number right here, right? Have benefits over mixed numbers. So they're all good answers for different reasons. I'm not going to say one is definitely better than the other. I like the red one because the fraction is reduced and it's not a mixed number. I like the mixed number one because that's how I would give somebody directions in terms like a distance. So pros and cons of all of them, different ways to state the answer. And again, with kids, we hope we're not working on a computer, that we have the real thing in front of us.